I'm going to sign up for Math 1 as I only got to pre-calc in high school. That's what they recommended.
Did you take trig in high school?
A little bit.
Okay. So the last thing you took was pre-calc trig?
Yeah.
As a combination? Should have been half a semester of trig or a semester of trig and a semester of pre-calc.
Yeah, that's what we did.
Okay. What's your course description say on the course that you're thinking of signing up on?
It says Math 1 reviews relevant techniques from algebra and precalculus, covers the manipulation and analysis of functions, including polynomial, trigonometric, logarithmic, and exponential functions, and an introduction to convergence and limits, continuity, rates of change and derivatives, differentiation rules, and applications to approximation.
Okay. So that's like Calc A. In other words, in high school, they probably had a course, well, maybe Kent did not, but most high schools have a Calc AB, okay?
Yeah.
Which covers what you're talking about, plus differentiation, plus gets into a little bit of integration. Integration would be more Calc B. It sounds like you're not going to get there. So it sounds like this course is going to be pre-calc and trig review, and then get started in calculus.
Mm-hmm.
The starting point for all calculus is limits.
Okay.
So if you want to work on something today, that's certainly something that I can make up enough stuff to fill our half hour here in terms of talking about limits.
Sure.
But that may not be where we want to start. Let me ask you, how comfortable are you with your pre-calc and trig skills?
You know, I have not done math at all since the final exam of my senior year. So.
Your senior year, so 3 months ago, or?
Yep.
Okay. Well, that's not bad. That's better than your junior year. That would have been 15 months ago.
That's true.
So let's see. What'd you get in that course that you took in your senior year?
I think I finished the year with a B+.
Okay. Well, you should be pretty good in that kind of stuff.
Okay.
And you don't have any specific review material that they've given you that would allow you to prepare?
No, they have not. That's what I'm a little like confused about, because all they've provided is just that course description. That's all they've provided.
Right. Well, they probably won't provide anything else to you until you actually start going to classes, and then they'll pour it on you. The first, I don't know whether it be a couple of weeks or a couple of months, maybe spent on pre-calc and trig.
Right.
And both of those are very broad subjects, and I wouldn't really know where to begin on either of those today for the next 20 minutes. However, where I can begin is with limits. Because it may be a situation where you only spend a week or two on pre-calc and trig, and then you go straight into calculus. And the dividing line is limits. In other words, limits are something that you've never really dealt with. Although, let me give you one that you actually have dealt with. It's just that you didn't know what it was. If I say the limits, in other words, they don't define this very well when you take pre-calc. What that means is what happens to this function, 1 plus 1 over x to the x power, as x gets very, very large. What happens to the function? You can kind of see the fact that the parentheses, inside the parentheses, is going to get closer and closer to 1.
Yep.
And so you're going to have a number like 1.000001 to the billionth power. Well, that starts approaching a number. And this actually does go to a number. Do you know what it is?
Infinity.
E.
E.
That's
I forgot
what it is.
E.
And that is 2.71, and then it just keeps going like pi. It's an irrational number. But you could prove that by just going into your calculator, put in 100 for x, you'll get 2.7 something, and put in 1,000 for x, you'll get the more precise number, and put in 1 billion for x, you'll get it out to 9 decimal places. And so you get more accuracy as you put in larger and larger numbers for x.
Okay.
And this is the only thing you've ever been taught about limits, and they didn't really even teach you much about this. Not everybody gets this part here fed to them in pre-calc. They tell you about E being 2.71, but that's about it. So let's talk about other kinds of limits. If I said, what is the limit of this function, x squared plus 5, as x goes to 3, what do you think that limit would be?
Is that where you?
Just directly substitute it.
Oh.
In other words,
14.
okay, there you go. So limit problems like this are pretty easy.
Yeah.
You can just substitute into the thing. The problems that get difficult is when direct substitution doesn't help very much. Let me think here. Let me talk about one other situation. If I have this, and I say, what is the limit of that as x goes to infinity? What do you think it is?
I mean, the answer is probably going to be a fraction, right?
Well, just think about making x bigger and bigger and bigger and bigger. What happens to the answer? In other words, if I make x 10, I've got 1/10.
Oh, it's going to get smaller.
100, it's 1/100th.
Yeah, it's going to get smaller and smaller.
Okay, so what do you think the limit's going to be?
0?
Yes. Okay. Now, it never will actually be 0. In other words, there is no size x you can put in there that makes that 0.
Right.
That's the essence of limits, is it's not what it's equal to, because I can't actually plug infinity in there. Infinity is not a number. But
right.
What this means is that what happens to this function as x gets bigger and bigger and bigger and bigger, what does it approach? Well, let's look at a graph of that function. Here's what that function looks like. It's hyperbolic in nature, right?
Right.
And it actually is on both sides. It's the traditional hyperbolic. And now if we look at it graphically, this is the x, that's the y. As x goes to the right, you can see what the function does. As it gets closer and closer and closer to this horizontal asymptote. And that's usually how you define a horizontal asymptote, is as x goes towards infinity, what happens to the function? Okay, so we can see a lot of things here. First of all, let's look at it graphically now. So we can definitely see that as x goes to the right, the y value approaches 0.
Mm-hmm.
So that's definitely the limit of 1 over x equals 0 as x goes to infinity. Now what happens as x goes to negative infinity? In other words, as we go in this direction,
Mm-hmm.
what does y approach?
0 as well.
Okay, so I could also say that the limit of that thing as x goes to negative infinity is also 0. Now, what happens as we approach 0? In other words, if I change this, so instead of approaching infinity, I'm going to approach 0, and might as well introduce right-handed and left-handed limits. If I put a little plus sign right there,
Okay.
it means I'm approaching 0 from the right side. If I put a minus sign there, it means I'm approaching 0 from the left side.
Okay.
Okay?
Makes sense.
So if you look at it graphically, what does y go to when we approach? And by approaching 0, x is approaching 0. So we're going in this, we're going in this direction, and we're going to get closer and closer and closer to 0. What happens to y?
It gets bigger.
Goes to what?
Infinity.
And that's the way you answer that. Now,
Okay.
let's approach it from the left. In other words, approach it from, we're approaching 0. Remember, in other words, that's what that means, is I'm going to approach 0 from the left.
Right.
What happens to y?
Gets smaller.
Well, what's the answer?
Oh, negative infinity.
Okay. Now, there is a rule in limits that says that if the limit from the right is not exactly the same as the limit from the left,
Mm-hmm.
the limit does not exist. So if I merely said, what is the limit as x approaches 0, it's not infinity.
Okay.
Does not exist. In other words, that's the very first thing that is required for a limit to exist, is the limit from the left has to be the same as the limit from the right. Now, classical limit problem that you kind of start with is where you just plug in and you get a number. So I could give you a number of functions, and what happens as x goes to 7, you plug in 7, and those are easy, okay?
Right.
The tough ones are always the ones where when you plug it in, you end up with 0 over 0.
Okay.
In other words, if I say, what's the limit as x approaches 1, and you plug it in, you get 0 over 0. And those are the hard problems. And those are, after the first hour or two of talking to you about limits, they will bypass all of the easy ones. Nobody needs to learn those more than about an hour because they're so easy. But the difficult ones are where you get 0 over 0. Before we talk about that one, let's just talk about the difference. If I have the limit of 1 over x as x goes to infinity, we know that that is 0. But let's talk about as x goes to 0. Okay, now we've already said that doesn't exist.
Right.
Let's say from the plus side. From the plus side, it did exist. It was equal to infinity.
Right.
So when you have the variable going to 0 in the denominator, and you have any number you want in the numerator, that could be 1, it could be 10, it could be 100, would not matter. As x gets little, the whole thing blows up.
Mm-hmm.
When I say blows up, it means it goes to infinity. Okay? If I look at the limit of x over 1 as x goes to 0 from the right, what does that go to?
0, right?
Yeah. And so here's really your two primary situations. And it doesn't have to be a 1. It's if I have x over any number and the numerator goes to 0, well, then my limit's going to 0. And if I have any number over x and x goes to 0, then my limit's going to infinity. So these two situations where you have your x in the numerator and the denominator are pretty easy also. We don't need to talk about those. In other words, that's something you just have to keep in mind.
Okay.
And now we get, oh man. Let's see. Let me see. I got to be an easier way to do this. This program has changed a little bit, and I haven't quite mastered it yet. I actually use a different thing now. When people send me material, I take a screenshot of it and I'm able to write directly on the material, which I found works quite a bit better.
Yeah.
Especially when you don't know how to use this program here. All right, let's get back to this one. And we're doing this as x goes to, in other words, if I say x goes to 2, well, this is an easy problem. What's that limit go to? Let's just, I'll assume it's a 2 there. I don't want to write it because I don't have to erase it.
All right.
So if x goes to 2, what's the limit go to?
So that's when you just plug in 2, right?
Yep.
For the x's?
Mm-hmm.
Okay, so or 3 over 2.
Oh, 3 over 1.
Yeah, 3 over 1.
Okay, and if I plug in any other number other than 1, it's basically trivial. In other words, if I plug in 7, then it's 7 squared minus 1 over 7 minus 1. The only number that gives us a problem is when x approaches 1. Because now by direct substitution, I have 0 over 0. And 0 over 0 is called indeterminate. It's the one thing where 0 is in the numerator and you don't know if the answer is 0. 0 over 0 can actually be negative infinity, it can be positive infinity, it can be negative 7, it can be positive 7, it can be 1/2, it can be all kinds of things. And that's why they call it indeterminate. Okay, well, let's do a couple of things to that function, like factoring. How's the top factor?
The top is going to factor into x minus 1, x plus 1. Right?
Huh? Different
Right.
difference of perfect squares.
Yep.
Now, that x minus 1 cancels with that x minus 1.
Right.
And you're left with that. Now, granted, you have a whole at 1, but I don't remember if you remember when you do something like that, it does not take away the domain restriction. In other words, when I look at this function, there's a domain restriction there. X can never be 1. I can approach 1, but it can never be 1 because you cannot divide by 0.
Mm-hmm.
Okay, so even though I factor the numerator and cross out the denominator, so I end up with x plus 1, I still have a provision attached there that x cannot be equal to 1. Okay?
Right.
But what's the limit of this as x approaches 1?
0.
Substitute.
So 0 can equal 1.
That. You're substituting 1 for x.
Okay.
So it approaches 1 plus 1.
Right.
That's the limit of 0 over 0, is it's actually 2 in this case.
Huh.
Okay? And we got it by factoring wherever we can and then dividing out common factors. And now let's see.
That's kind of weird. I thought 0 over 0 would just be 0.
No, it can be anything. In fact, it's rarely 0. That's not even the most common answer. But the thing is, it's indeterminable. You don't know what it is until you do further work on it. I was going to say something. Well, I lost my train of thought. Let me think for a second. What was I going to do? Oh, yeah, I wanted to draw a picture here. I'm going to draw a piecewise function. You remember piecewise functions.
Yep.
So let's look at some of these graphically, these limit problems. If I approach 2 from the left, what is the limit? I don't even know what this function is. In other words, I could lay this function out, but I don't have to know what it is. So all I have to do is figure this limit problem out graphically, and I can do it. Okay, so as I approach x from the left, which means I hop on board the function and I start traveling towards 2. What's the limit of that?
3?
Yeah, in other words, this is going to be called f of x is our function. And so I can say the limit of f of x as x approaches 2 from the left equals 3. What's the limit of f of x as x approaches 2 from the right?
5?
Yep. The way to do these, the way to think about these, is to hop on board the function. Don't really look at the x-axis. Hop on board the function. So here I'm hopping on board, and I'm going to travel towards the number 2. Okay, I'm not going to ever reach it. I just want to know what I'm approaching on the y-axis. And so that is 5. Okay. Now, if I said, what is the limit of my function as I approach 2, what's the answer?
The limit of the function as you approach 2? 5 again?
No, it does not exist. Remember that very first rule of limits.
Yep.
It has to agree from the left and the right. It can't be different. Okay?
So the function does not exist.
The function does not exist. Now, let me give you another one that is not obvious at all. Make this value 3 again. Another piecewise function. I'm going to call that 6 just to differentiate it from the other. And this is f of x again. So if I want the limit of f of x, and you know what this means, right? In other words, the value of the function is the solid line until I get to 2. And then the value of the function is 6. And then I go back at 2 only, it's 6. But then as soon as I get to the right of 2, it goes back to close to 3. Okay?
Right.
So what's the limit of f of x as x approaches 2 from the left. And this is going to surprise you. All of these answers are going to.
So as it's approaching 2, then it doesn't actually get to 2?
It never gets to 2. So what's it approaching on the y-axis as you approach 2 on the horizontal axis?
3.
Okay. And if I approach it from the right, what is it?
3 as well.
Okay. So now that allows me to say, what is the limit as I approach the number 2?
3.
Yeah, it's not 6.
No. Okay.
In other words, this approaches, as it approaches 2, the y value approaches 3. This way, as I approach 2 on the x, the y value approaches 3. It really doesn't matter what its value is at 2. In other words, if I said, well, what's this? What's f of 2 equal to?
6.
Yeah.
Whoa.
Now, you've got the limit as you approach 2 being 3, but f of 2 is actually 6. So this is where limits start getting a little non-intuitive, because if you gave this problem to a bunch of people, most of them would say it's approaching 6.
Yeah, that's what I thought at first.
2, but it isn't that. Okay, and there's I won't take any more of your time other than just a minute here. There are actually 3 techniques that you have to learn to solve limit problems.
Okay.
And we only talked about one of them, factoring. And you were able to see that we started out with 0 over 0, but we ended up, after we factored, with something different. It was x plus 1. Well, you have similar problems with trig. If I said, what's the limit of this as x approaches 0, I again get 0 over 0, but the limit of that turns out to be 1. And this is a lot harder one to do. I can't factor that and solve it. This is kind of one they tell you to memorize. Calculus has a problem in that they can't teach you how to do this without more calculus, but you have to know this answer before you can get more calculus. So it's a catch-22 situation. And so they give you this one and they say, memorize that the limit of sine x over x as x goes to 0 is equal to 1. And then later on, they'll show you how to prove that, or how to show that that's equal to 1.
Cool.
Okay. So that's a pretty good intro to limits.
All right.
And that's always where you start once you get into calculus. Like I said, you may have a period of time where you're doing pre-calc and trig, and boy, certainly if you need help or review on that, I'm here. But I don't know how long it'll take for you to use this limited little piece of information on limits in class. Maybe right away. I don't know.
Yeah, you never know.
Well, I would think that anybody that's at Dartmouth is going to have pretty good skills in pre-calc and trig. In other words, they're not going to have been failing students. So it's not like a lot of colleges where they will have to spend a lot of time reviewing the stuff you're supposed to already know. So you may get into limits sooner than I think.
Yep. We'll see.
But anyway, yeah.
So would you recommend that we talk like more before I get there, or should I just call you again once I get there and have some questions?
It's really kind of up to you. I have found that it does actually kind of help to get students a little bit ahead, so that by the time you get into the lecture where they start talking about limits, it won't sound all Greek to you.
Okay.
In other words, if you have a little bit of pre-familiarity with it, then you're going to be able to absorb the information better when your teacher lectures you at it. Because a lot of
Right.
times, especially when you're dealing with totally new subjects, I'm sure you felt this way when you first started trig, although they teach trig a little differently now. In other words, they give you a little bit of trig in every year of high school.
Mhm.
But when the very first time you're introduced to it, it's like Greek. It's like a foreign language, and it tends to overwhelm you a little bit. And limits can be a little bit the same way. So
Okay.
whatever you want. I've got plenty of time. We're still on reduced summer rates here. I only charge $10 per half hour up until the end
Oh,
of August. So if you want to get a little ahead of things, then by all means schedule some more appointments. I don't know. Are you still doing tennis 24/7, or are you taking a little? Will you take a little bit of break from tennis when you go to college?
no, it starts right up when I
Really?
get there.
They don't give you a break
Yeah.
at all, huh? And
No, got to learn how to deal with it right from the
wow,
start.
how are you gonna? How can? Well, you've done that at Kent for four
Yeah,
years, so
you know,
you got
Dartmouth will be a little
experience
different.
how to mix school with tennis. But do you have any idea how good their tennis team is?
Yeah, they um 2 years ago they finished in like the top 30, which is really good.
Uh-huh.
And then last year they had kind of an off year. They lost some good players and stuff.
Mhm.
So they didn't do as well last year. But then this year they're getting me plus four other freshmen and like a junior or
Yeah.
something. So
Where do you
hopefully,
expect? Do you have any expectations as what you'll play? I mean, number one,
um,
two, three. What? Any idea?
probably a little lower than that, maybe like 4 and 5.
Okay, but
Just
you'll start right out on varsity. They don't have a JV that.
no, the team's not that big. There's only like 12 guys on the team,
Okay,
and so we're all yeah, it's all one team, and
you'll still play singles and doubles.
hopefully,
Yeah.
I'm hoping.
Yeah.
So been working pretty hard. Went for a little run this morning to try to
I'll
keep
bet.
up my
I
fitness.
actually
And
watched you at the Denver City Open when they live streamed it.
oh, really?
Yeah, they were live streaming on courts 1 and 6 that day when you were
Oh, that's awesome.
when you got to the quarterfinals, I think.
Yeah, that
And
that guy played
yeah,
the quarter. Was
it was,
good.
it was a little hard to watch on live streaming because they don't give you much information, but still, it was kind of fun.
Yeah, that's cool. Thanks for watching.
Yeah, no, I hope you become a big star. That'd be fun to know somebody that was a
Yeah,
professional tennis player. I don't know. Do you have aspirations of being a pro or?
yeah, I do.
Okay, cool.
I was gonna play a pro tournament this summer, but then it just didn't really. We had to go to like my cousin's wedding, so it didn't really work out.
Uh-huh.
But
Huh. Well,
so we'll see.
good.
Hopefully.
Yeah. All right, Casey. Well, enjoy the rest of your summer in Colorado. It doesn't sound like it's going to last too much longer. So,
No, not too much.
all right. I'll
So
talk
we'll,
to you later.
all right, talk to you later.
Bye-bye.
Bye.